Hello friends, hope you are all doing well. Our today's topic is storage types of database tables in SAP HANA. It is my fifth lecture of the playlist Introduction to ERP, SAP and HANA. In this video, we are going to learn in how many ways data is going to be stored in the backend, that is in the database server, their properties and differences. And also let's know what is database table and how the data is stored in it. A database table is nothing but a table containing some information in the form of rows and columns, like how we usually maintain the data in Microsoft Excel. In database related softwares like SAP, SQL, and Oracle, etc., rows will be calling with records and columns with fields. If you see in this picture, this is a database table with some fields and records. In real time, business users or end users will be working on this and they feed each entry into the table. After inserting all the entries, this is the way the table looks like with final data having 4 fields and 5 records. And here there is a term called logically right. What does it mean? This tells us that this table is just a representation of the original database table which is stored in the database layer or database server. Moreover, it is just a structure with some fields in it and it is stored in application server. When a query is written, the data which is present in database layer gets loaded into the table present in the application server and gives the output to the user. And here you have heard about application layer and database layer, right? I have already explained this in detail in my third lecture, which is Architecture and Layers of SAP. If you missed to watch it, please watch that video, which is available in this playlist itself. And here, the database table what we are seeing right now is actually present in the application layer. This is not in the case of database layer. In backend, that is database layer, the data is stored in a different way, and majorly there are two ways in which the data is going to be stored. So, storage types in database tables, that is in SAP HANA database, are of two types. One is row-based storage type and another one is column-based storage type. Let's learn about each of them in detail by knowing their properties. Primarily, there are 4 properties involved. Firstly, physical storage in HANA database, which is in the backend. It defines how the data is actually stored in the backend, that is in the database server. Secondly, creating an entry in database table. It states that if an entry is created, what would be the impact while choosing the storage type in database table, either as row store or column store. Thirdly, rate of compression. It is nothing but eliminating or removing the entries which are duplicates whenever we find multiple entries with same data exists. Lastly, it is creation of secondary index. We choose this property when we want the output with high performance in less interval of time. Basically, there are two types of indexes available in SAP HANA database. One is primary index and other is secondary index. By default, primary index will be assigned to a database table with some key fields. So, whenever a search operation like read, modify, update, etc. perform, the data will be fetched based on those key fields provided by the primary index. In some cases, even though primary index is defined, there is raw performance to process or fetch the data. In that case, additional fields are assigned by creating a secondary index so that data can be processed or retrieved faster. There are still many properties involved, but these 4 are the major ones. Let's know more about each of the property in detail. Physical storage. In a row store method, each row of data is stored one after another in a sequence like row 1 data, row 2 data, and so on. Here we are seeing each row of data, right? It indicates that one single complete record with full set of fields. So one complete record with all the keys involved is called one row of data and it is stored one after the other. So in the database server level, data can be arranged in this format. Here in row store, Data is arranged in such a way that after one complete record with all the fields are placed, then only the second row of data is placed next to it. And similarly, row 3 data and row 4 and so on. And here we are able to see that one row of data is placed next to another row of data, right? This pattern continues for a few number of records. As there is length restriction, it means only a limited data up to certain length can be occupied in one single line. After reaching to the end, it will shift towards the second line and continue filling the data. And if the second row of data is also filled, it will shift to third line. This continues till all the records in the database table is displayed. So for clear understanding, row store data can be displayed in vertical format also. Instead of displaying data horizontally, just we are displaying in this format. Both are same, but for better understanding, I have shown it this way. There is nothing difference. Here also the row 1 data is displayed and after that only the row 2 data is displayed. Similarly, row 3, row 4 and row 5. It is displayed one after the other. In case of column store, each column in the database table acts as an individual table or an individual mini table and data gets stored separately. In this table, we can see 4 columns: employee ID, employee name, employee gender, and employee salary, right? So each of this column will be forming as an individual table. Here, employee ID related data is stored at one place separately and this forms as an individual table. Similarly, employee name data is stored at one place and forming second individual table. Employee gender is storing at one place, forming third individual table, and employee salary data is stored at one place, forming an individual table. Now, if we see the vertical arrangement of the column store data, the same appears here also. We can see all the employee ID column related information at one place. Below that, employee name related data is displaying, and below to that, employee gender related data is displaying, and at last, employee salary related information is displaying. So as there are 4 columns, 4 individual tables are created and data is getting stored separately as a column wise. Second property is creating a record or an entry. In row store, whenever a new record is created in the database table, it will append at the end of the last record. So here already there are 5 entries in this table, and if the user tries to create a new entry, it will append as a 6th record at the end of the 5th record. And the data is placing side by side here. In case of vertical arrangement, the same happens. It's also going to create at the end of the 5th record. So here 6 by 1 indicates it is a 6th record with first field, 6th record with second field, 6th record with third field, and 6th record with fourth field. Whereas in case of column store, new record has to settle in the respective columns where they are stored as an individual tables. In employee ID mini table, a new field will be added. Similarly, in employee name mini table, new field will be added and so on. And this is how the data is going to fill in case of column store. The data is splitted and stored at different places. To fill the data, it has to travel long from one column to another column. And in case of vertical arrangement, the same will happen here also. In each column individual table, new entry will be adding at the end. And moving to the third property, which is data compression. In case of row store, even though we try to compress the data, there is no change at all. This is because in row store, the data contains mostly as unique or distinct values, means there are no repeating entries found. But in case of column store, there is high impact in data compression. This contains the data where for the same kind of value, there are multiple entries available. If you see this employee gender column, which has repeating entries for the same value, like male is repeating 3 times and female is repeating 2 times. So this can be compressed, which reduces the storage space in the database. So after compression, which means removing the duplicates, we can see that only 2 entries, that is male and female. Along with compression, there is indexing, which means data is sorted in either increasing or decreasing order. If nothing is provided, it will automatically consider ascending order by default. So here indexing means sorting in an order either by ascending or descending, and ascending by default. So here in each and every column individual table, it will refer all the entries and it will sort according to the order given by the user. And this index is different from primary and secondary index what we have seen earlier. And the last property is secondary index. In row store, the data fetching will be little bit slower. So there is necessity of creating secondary index to achieve faster results. In case of column store, in SAP HANA database, the database itself will perform the task in such a way that results can be produced very fast due to its in-memory database engine. What is this in-memory database and all? We will be learning in the upcoming lectures. So far, we have seen some properties and effects like what if data is stored in database table in row store or column store. Also, previously we have discussed feeding data into database table is end user job. But to feed the data, there should be a table exist, right? And also, you might get a question like when to choose column store or row store while creating a database table. So here comes the role of an ABAPer. He would decide which storage type to be selected, either row store or column store. Based on the properties what we have seen so far and the business requirements, he will create it accordingly. And there are certain things where ABAPer will take into consideration before creating a table. Let's see what are those prerequisites. When an ABAPer got a requirement like his database table should contain less number of rows and more number of columns, then he would go with row store creation. Else, if he wants less number of columns and more number of rows, he would choose column store creation. When majority of the values are distinct or unique, then there is no scope for compression. Then we can choose as a row store. But in case of column store, as we know that the values will be repeating continuously and compression can be done on this, in that case we can go with column store. Example of row store tables. Mainly we can see the configuration tables like T bookshop, SLIN CHCK. And these configuration tables can also be called as customizing tables or organization tables. And some of the examples of column store are master tables and transaction tables. And what are these configuration tables, master tables, and transaction tables? We will be seeing them in the further lectures. When there is a scenario that one complete record with full set of fields need to be accessed, in that case, we need to choose row store. Let's illustrate more on this. If we see here, identical data is storing side by side. Here, identical means one set of record is storing side by side. So, whenever a read operation is performed, the data can be fetched easier. But in case of column store, if one record needs to be chosen, it has to travel all the individual tables and get the data. So, it is a time taken process. But to fetch one record with specific columns, this can be used. Why? Because it has to scan only few column individual tables. In real time, we will fetch only fewer columns rather than fetching all the fields. When there is no need to perform aggregation and quick retrieval of data, then it is better to go with row store. In case of column store, it is a high performance. Aggregation means sum, maximum, minimum, count, etc. And also, if there is a query like to fetch the sum of all the employee salaries, in case of column store, it will go directly to employee salary column individual table and it will sum up all the values and gives the data within no time. Whenever there is insert operation like creating entries into database table, it is better to choose row store. As we have seen earlier, a new record will be placed at the end of last record side by side. And this process is called OLTP, which stands for Online Transaction Processing. And whenever such operation is performed like read, update or modify with few fields, then column store serves better. This is called OLAP, Online Analytical Processing. And there is one important feature in column store, that is Parallel processing. So in case of column-based storage, multiple operations can be done on a single database table using multiple processor cores. And also if multiple columns needs to be aggregated, this method helps us by saving a lot of time. For example, in this table, we have seen one column operation is done on employee gender column, right? Similarly, if there is any repeating data found in any of the column, that also will be done parallelly by assigning it to another processor core. And also in employee salary column individual table, we have seen addition operation is performed. Also, if a query is written like, I want to get the exact count of employees, then count operation is performed on the employee ID column individual table by assigning it to another processor core. Lastly, operations on one column can be parallelized by partitioning the column into multiple sections that can be assigned to different processor cores. If you see in this picture, each operation in each column is performed by assigning to each processor core. And in column C, as there is huge data, so to get the results faster, it is splitted and assigned to different processor cores. Here you are seeing the processor core, right? What is this meant by? For example, if any software or application needs to be installed on laptop, there are some minimum hardware configuration required, right? Like Windows 10 operating system, it should be there, and 64-bit processor should be there, etc. So as this is completely on SAP HANA database, here also there are some hardware configurations defined. Like a system should have 4 layers minimum and 8 processors and cores depending upon the laptop what we have chosen. So if you see the specifications of this ASUS laptop, it is 12th generation Intel processor, and here H stands for high performance, and it is of i5 processor. And here you can see 12 cores, right? Where 4 indicates 4 processor cores and 8 indicates 8 efficient cores. So 4 layers, 8 processors and 12 cores are there. Multiplying all these will get the actual number of core processors, which is 384. So each core is assigned to each processor in case of parallel processing. And one last thing is left, which is important. So far we have seen data storage types like row store and column store, right? But where we can see actually in the SAP system. So for that, let's log in and see in the system. I have logged into SAP system, and we can check the database by going to the status. And here you can see the database system is HDB, which stands for HANA Database. We will take one example from each and check in the SAP system. Here T bookshop. For this we need to go to the transaction SC11 and give the table name like T bookshop. Go to display and go to technical settings. So here you can see data class as APPL2, right? Which stands for organization and customizing data. And in the DB specific properties tab, we can see that the storage type is row store. Similarly, we'll check for another table, which is VBAK. Go to display, technical settings. And if you see in the data class, it is transaction data. So as this is transaction data, it should be as column store. So if you go into database specific properties tab, we can see here this is column store. And also there is a table which gives you the list of all entries, which tables are of row store and column stores in SAP. For that, again we need to go to transaction code SC11, and the table name is DD09L. Go to display and go to contents. Here you can see one field like row or column store. So if you click on this F4 button, you will get R stands for row store, C stands for column store. For now, I will choose R. And if you execute this, we can see this all the tables are row store tables. Similarly, if you give C, which stands for column store, and execute, these are all the tables which are maintained as column store. This is all about the storage types in SAP HANA Database, and I request you to kindly go through this video and listen keenly to get better understanding. And here are the key points so far we have seen. Please have a look. And there is an important point. Suppose there is a database table created with row store type. Again, we thought of no, it should be as column store. It is easy to change in the application layer by simply choosing the radio button. But it will be more burden for database layer to make all the records to column store and many operations which is not a good thing. So we need to decide in the beginning stage itself. I will show you an example. This is the database table which I have created, and if you go to display, these are the 4 fields which you have seen in the example what I have given: employee ID, employee name, employee gender, and employee salary. So if you go to the content and execute, you can see the records, and these are the records. There are 5 records with 4 fields. Forget about this MANDT field as of now. We will be discussing this all in the upcoming lectures. So here, if you go to technical settings and database specific properties, here it is row store. Here, by going to the change mode, simply we can make it changes to column store. But the changes what we are doing, this is in the application layer. But in the backend, that is in the database layer, it has to see all the data, whatever it is there, and it has to convert the data into column store, and whatever the operations are performed on each of the columns should be again do analyze and change it to column store, which is a burden for the database table. So while creating a database table itself, we need to decide. And there is a note point: whenever we are not sure about which data storage should be chosen, better to go with row store as it is less restricted. Thank you, friends. Hope you have learned more content in this video. Our next topic will be on data compression in column storage. This will be in depth of what we have seen the compression property in this video. Until then, keep learning and share the knowledge. Please keep supporting me so that I can provide you much content with great enthusiasm. Thank you once again. Jai Hind.